Hello friends, in today's question, consider an elliptically shaped rail PQ in the vertical plane with OP 3 meter and OQ 4 meter. A block of mass 1 kg is pulled along the rail from P to Q with a force of 18 Newton, which is always parallel to the line PQ as in figure. Assuming no frictional losses, the kinetic energy of the block when it reaches Q is given as n into multiplied by 10 joules. The value of n, take the acceleration due to gravity as 10. So this is a figure. So block of mass 1 kg is taken from point P using this elliptical orbit or shape to point Q. And we are supposed to find out indirectly the value of kinetic energy, and which we can equate with the given kinetic energy, that is n into 10 joules, and we can find out value of n. So in this case, we can say that the block is taken from P to Q and it follows the elliptical path PQ, but the displacement will be the hypotenuse of this triangle QOP. So you can say that block is taken from point P to Q, and this is done along the elliptical path, along the elliptical path. So from here we can find out that the displacement of the block, therefore the displacement of the block will be equal to hypotenuse PQ of triangle QOP. Therefore, we can write the value of PQ as, so hypotenuse PQ will be equal to, this is a right angle triangle, so this will be equal to 3 square plus 4 square square root, and this will be equal to 5 meters. And so we can say that this is a displacement, and let us denote it by S. Now it is also given that force is acting always parallel to line PQ. It means direction of the force as well as direction of the displacement is same. Okay. So from here we can say the direction of displacement is same as that of force. Therefore, the angle between them will be equal to 0. The angle, let us suppose theta, between the two is equal to 0. We already know value of the, you can say, formula for the work done. So we can say work done W will be equal to F dot S, and we can say Fs cos of theta. Theta we already know is 0, so we get work done W will be equal to Fs, and force applied is 80 Newton, and the distance is 5. So from here our work done will be coming equal to 90 joules. Now, as the block is moved from point P to point Q, the height which is traversed by the block is 4 meter. Therefore, the potential energy gained by the block will be mgh, where mass is 1 kg, g is 10, and h will be 4 meters. From here we can write potential energy PE gained by the block will be equal to mgh, mass is 1, g is 10, and h is 4. So we get potential energy will be equal to 40 joules. So here we know the value of the work done, which is W 90 joules, and potential energy is 40 joules. So the block here consists of two types of the motion. One is which is moving in the height, along with that there is a velocity. So work done will be a combination of potential energy as well as the kinetic energy. You can say, but work done is equal to potential energy plus kinetic energy. We substitute the values, we get 90 is equal to 40 plus kinetic energy, and from here we can say kinetic energy is equal to 90 minus 40, which is given as 50. And it is also given that the kinetic energy of block at point Q is n into 10. Okay, you can say, but kinetic energy at point Q is equal to n into 10. So we can equate these two equations. We can say 10 into n is equal to 50, and 50 we can write 10 into 5. So from here we can say that the value of n is equal to 5. This is our final answer. This completes the question. Thank you.